What if I told you that everything you love about science fiction, the starships, the alien sunsets, the idea of humanity spreading across 1,000 worlds, is a fantasy we will never live to see? Not because we're not smart enough, not because we're not brave enough, but because the universe itself was built to keep us in. Welcome to the prison you didn't know you were born into. For most of human history, far away meant the next valley, the next continent, the next ocean. Then we looked up. We sent probes past Mars, past Jupiter, past Pluto. We watched Voyager 1 slip beyond the edge of the sun's influence and become the farthest human-made object in existence. Surely, we thought, the stars are next. But here's the number that breaks that dream. Voyager 1 has been flying for almost 50 years, at over 60,000 kilometers per hour. And after all that time, all that distance, it has covered less than 1,000th of the way to the nearest star system, Alpha Centauri. At its current speed, it would need over 70,000 years to get there. 70,000 years to reach our closest neighbor. Not the edge of the galaxy, not some distant cluster, our neighbor. This is the monster we have to talk about today. Not aliens, not black holes, distance itself. Space is not just big. Big doesn't cover it. If you shrank the sun down to the size of a grapefruit, Earth would be a grain of sand 30 steps away. And Alpha Centauri, our nearest stellar neighbor? On that same scale, it would be over 7,000 kilometers away. The gaps between stars aren't gaps. They're oceans. And we are standing on the shore with a rowboat. So we build faster rowboats, right? Let's try. Chemical rockets, the kind that got us to the moon, are laughably slow on a cosmic scale. Useful for hopping between planets, useless for reaching another star. So scientists dream bigger. Nuclear pulse propulsion, detonating small nuclear bombs behind a ship to push it forward. It sounds insane because it is, but it could theoretically reach a few percent of the speed of light. Still, at that speed, Alpha Centauri is over 100 years away. One way. For a crew that would need to survive in a metal tube for a lifetime, just to arrive as strangers in a system no one back home would live to hear about. What about antimatter engines, the most efficient fuel physics allows? A gram of antimatter meeting a gram of matter releases more energy than a large explosion, except we've only ever produced a few billionths of a gram of antimatter at a cost of billions of dollars, and storing it safely for a multi-year voyage is a problem we have no idea how to solve. Then there's the fantasy fuel of true science fiction, the warp drive, bending space itself so a ship never technically breaks the speed of light, while the space around it does the move. On paper, the math almost works. A real equation, published by a real physicist. In reality, it requires something called negative energy density, a form of exotic matter that, as far as we know, does not exist anywhere in our universe. We are not close. So maybe speed isn't the answer. Maybe patience is. What if we don't go fast? What if we just go long? Generation ships, vast, self-contained worlds sent drifting toward a distant star, carrying not one crew, but generations of them. Children who will die before arrival, so that their great-great-grandchildren might see a new sunrise, might step onto soil none of their ancestors ever touched. It sounds noble. It also assumes a closed ecosystem can survive centuries without collapse, that social structures can hold together across dozens of generations without fracturing, and that the ship itself won't fail long before the mission does. We have never sustained anything like it, not even for 100th of the time required. Or what about sleep? Hibernating the crew, slowing their biology to survive the centuries in a dreamless pause. It's a favorite of film and fiction, but human biology fights back at every stage of long-term stasis. We do not know how to safely suspend a human body for decades. Every solution we invent runs into the same wall. Not a wall of imagination, a wall of physics. And this is where the story usually turns bleak. But here's the pattern interrupt. The wall isn't just physics failing us, it's physics protecting something. The speed of light isn't a cruel prison bar. It's the reason cause and effect exist in an orderly way. The reason a star can burn steadily for billions of years instead of collapsing instantly. The reason chemistry has time to build atoms into stars, stars into planets, and planets into us. The very slowness that locks us out of the stars is the same stillness that let life have enough time to happen. Maybe the universe was never designed to be traveled. Maybe it was designed to be watched. Because we still have starlight, ancient photons that left their source thousands, millions, sometimes billions of years ago, traveling in silence across the void just to land for one instant in a human eye. When you look at the night sky, you are not seeing distant places. You are seeing distant times. A living fossil record of the universe, delivered to Earth for free. We may never set foot near another sun, but we already touch those suns every night, whether we notice or not. So maybe humanity's future in space was never about conquest. Maybe it was never about flags on new worlds or footprints in alien dust. Maybe it's about becoming the species that finally understood its own solar system so completely, so intimately, that it never needed to leave to feel like it belonged to something vast. We are not trapped in a cage. We are standing in the one place in the universe warm enough, stable enough, and old enough for something like us to exist at all. Staring out at a sky we can see, but were never meant to touch.